Hello, my name is Taylor Orzo, and this video is for the Equilibrium Lab number 6, and the first reaction we'll be analyzing is reaction E. So the first question is, what color is the Fe3 plus ion? And the answer is yellow. And I'm going to reference the Upper Canada District School Board for that answer. Also, for what color is the SCN minus ion, and that ion is actually colorless. And thirdly, what color is the FeSCN2 plus ion, and that is a dark red color. The next question says, explain the color change that occurred when KSCN and FNO3 were mixed. So, when FeNO3 mixed with KSCN, a dark red, almost black color formed because Fe3 plus and the SCN were both in the reactant section. For number C, or for letter C in part E, the question says, explain the color changes that occurred when heat was added. So when heat was added to FeNO3 plus KSCN, the solution turned an orange clear color because the temperature was increased, which increases the concentration of the reactants. This is from jove.com. And when the concentration of the reactants is increased, the reaction will shift towards the reactants, so it'll shift to the left to get back to equilibrium, resulting in a lighter color. The next section of E asks if the reaction was exothermic or endothermic, and since the temperature increased, this means heat was added, so heat was a reactant, meaning it was endothermic. After that question, it says, explain the color changes that occurred when excess reactants were added. So, when extra KSCN was added, this made the reactants preferred in the reaction, meaning that the reaction needed to shift to the right. And to do this, the extra KSCN needed to react with the FeNO3 to create more product, and the mixing of these two resulted in the scarlet color we got before. The next question says, what precipitate formed when AgNO3 was added? Explain the equilibrium shift that occurred when AgNO3 was added. You might find it helpful to consult a solubility table. So when AgNO3 was added, the equilibrium shifted to the left because the SCN was removed. By removed, it means it reacted with the AgNO3. And AgNO3 was the precipitate created. Now, what precipitate formed when NaOH was added? And explain the equilibrium shift. When NaOH was added to the solution, so NaOH added, the reaction shifted to the left as well, because the product became favored to restore the Fe3+ ion that was reacted. So that completes the questions for E. And then the next reaction we're going to focus on is reaction A. And this had to deal with mostly pH. So the first question in A is explain the significance of the first pH. So the first pH measured was that of acetic acid, and it was 4. So anything, so 4 is less than 7. So anything less than 7 is acidic, and that was taken as a reference to see how it would change when sodium acetate was added. So the next question, it says, explain what happened when sodium acetate was added. Well, when sodium acetate was added, the pH became 6. So the solution became more basic, 6 being closer to 7, because according to chemistrystackexchange.com, sodium acetate makes acetic acid, a weak acid, dissociate 100% into ions by stealing H+ ions to create a basic solution, since bases are proton acceptors. Okay, the next reaction would be, oh, it's not B. The next reaction we're going to analyze is F. And the questions in F start with, what product was removed by aspiration? Well, the product that had to be removed during aspiration was the acid, because when it was removed, the solution became more basic. And then it says, explain the indicator color change. The indicator color change turned blue because HCl was removed. And if the pH is more than 7.3, it turns blue. So when it did turn blue, it indicated that the solution became more basic. Causing the indicator to turn blue. Thank you very much.